Hey everybody, it's Mr. Gar again. Today we're going to be looking at 5.1 day 2. We got some more identities to cover with this. To start, we're going to talk about our cofunction identities. Okay, and these are again things that you have talked about in the past, but we want to label them as a specific identity. So the idea of this is that if we take the sine of theta, that's the same as the cosine of pi over 2 minus theta. Okay, where you've seen that in the past is if I have this triangle, for example, we know that if that's theta, my other angle has to be complementary for 90 degrees, or in this case, pi over 2. So I could always take pi over 2 minus theta to represent that. So when I do this one, if I look at the sine of theta in this case here, the sine of theta is A over C. Okay. But when I take the cosine of my pi over 2 minus theta, so I'm taking the cosine of this angle here. Cosine is adjacent over hypotenuse, so it's still A over C. That's where these cofunction identities come from, okay? So they always line up this way. The sine is the same as the cosine of its complementary angle, so that's what it looks like there. Same with this one here. Tangent is the same as the cotangent of its complementary angle, so that pi over 2 minus theta, okay? And then same thing with secant and cosecant. They are the same as is that reciprocal, or not reciprocal, complementary angles there. Okay. Odd and even identities. So odd and even identities, if we take the sine of negative theta, that is the same as negative sine of theta. Okay. Same thing with cosecant. Cosecant of negative theta is the same as the negative cosecant of theta. The reason why is because this is odd. Here's my sine function. Here's just one period of it. Okay. So if I look at, for example, this value, okay, that is a positive pi over 2 and then positive 1. But if I do the negative pi over 2, that gives me a negative 1 as the output, okay? So we get this odd symmetry here, okay? But when I look at cosine and secant, the cosine of negative theta is just cosine. The secant of negative theta is just secant. The reason why is because we have even symmetry here. So again, what that means is, let's say I go out here to all the way out to pi, that gives me a negative 1, okay? So the cosine of pi is negative 1. The cosine of negative pi is also negative 1. It's the same value both ways, okay? So that's why so with that even symmetry, that's why we have the input of that negative theta is the same thing. Tangent and cotangent is also going to be odd, okay? Since these are odd, the positive version goes up here. If I go the negative version, it goes down to the negative. So like positive, positive will actually go negative, negative when I do this one. So that's the same idea with these. Okay. So we're going to use these to help us find our different values here. Okay. So if cosine of x is equal to negative 0.75, find the sine of x minus pi over 2. So first thing is I want to manipulate this sign here. Oops. This sign right here using our cofunction idea and our also our odd identity. So the sine of x minus pi over 2, that's similar to if I do this. If I factor a negative 1 out of the x minus pi over 2, that's the same as taking negative pi over 2 minus x. Okay. I'm doing that on purpose because I want this to look like the sine of negative theta here. Okay. So by doing that, what I know is this is going to result in the negative sine of pi over 2 minus x. Okay. So that's using the idea that the sine of negative theta is equal to a negative sine theta. So I'm sort of pulling out a negative sign here. Well, remember what this is representing. The sine of pi over 2 minus x is the same as the cosine of, well, it should be put in terms of x. This is the same as the cosine of x, okay? These are the complementary angles. So that means I can replace this with cosine of x. So it's going to be negative of cosine x here. Well, if it's the negative of cosine of x and the cosine of x is equal to this, what I'm taking is the negative of negative 0.75, which is equal to 0.75. And that's what the final answer is. That's what the goal was to get to this value here, okay? Okay, cosine of x, 1 over cosine of x times 1 minus sine squared of x. Okay, so when I do this one here, we're going to try to use our Pythagorean identities along with our other identities here. So one thing I noticed is 1 minus sine squared of x. Since I'm dealing with sine squared, go back to my Pythagorean identity, sine squared x plus cosine squared x equals 1. I can change this around a little bit by subtracting sine squared x over. If I do that, I get cosine squared x is equal to 1 minus sine squared x. Since this matches this, I can replace that with cosine squared x. So 1 over the cosine of x multiplied by the cosine squared of x. Well, since this is cosine squared x over 1, it's kind of like saying x squared over x. We can simplify this out, cancel one of these out, and then this will actually turn into just the cosine of x. And that's it. That's our goal here, was to simplify. And that's what we've done. So we're using identities and we're trying to simplify these as best as we can, using like a combination of things to work through. Okay, so simplify by factoring. Once again, I'm going to look for, in this case, whatever. It says simplify here. I know it's not showing up on your screen, but it's fine. Okay, simplify the cosine of x times the tangent of x minus, oh, actually, you're missing a few things. I'm sorry, 1 second here. Let me go back. There we go, that's fixed. Okay, we want to simplify this expression. Cosine x tangent x minus sine x cosine squared x. Same thing. Once I see this, I'm going to start thinking about my Pythagorean identity here. Okay, so that's going to be just a kind of a heads up for myself. But I'm not going to do anything yet to replace it. I probably could, if I wanted to put that in there, I could, but it gets a little bit complicated because it's sine of x times that. So since my kind of clue here is factoring, let's see if I can rewrite some stuff. First thing I'm going to rewrite is tangent. Remember, tangent is the same as sine divided by cosine. So I can take this as cosine multiplied by sine of x over cosine of x minus sine of x cosine squared of x. Okay. My reason for doing that is now these two cosines will cancel each other out. So this part simplifies to just sine of x. Okay. Well, now I've got sine of x in both of these. This is where the factoring comes into play. Since I have sine of x in both of these terms, I can factor out sine of x. So when I do that, I got to take it out of both terms. If I take it out of here, I'm basically dividing it out or factoring it out, or I just think of it backwards. Sine of x times 1, okay, if I distribute with that, that's going to get back to sine of x. Sine of x times a negative cosine squared of x will get me back to that original one as well. So that's me factoring out sine of x. Now I can think about my Pythagorean identity. 1 minus cosine squared of x is the same thing as if I take this one up here, subtract cosine squared of x. So sine squared x equals 1 minus cosine squared x. Meaning, sorry about that. So since we got sine squared of x is the same as 1 minus cosine squared of x, and that's what I have here, I can now replace that with sine squared of x. So sine of x times sine squared of x, and we are multiplying by another sine of x here, so it's like another factor there. So this is going to turn into sine cubed of x. Okay, it's just like taking x squared times x is going to be the raised to the third power now. All right, and then let's see, I think 2 more examples. Okay, so this one here, we got secant of x, 1 over 1 minus secant of x, minus secant of x over 1 plus secant of x. This one's a little bit tricky, but we're combining fractions here. So what we want is we want to have common denominators. So with these cases here, the best bet to do is to multiply it by basically the conjugate. 1 times secant of x, 1 plus secant of x here. Okay, that will turn both of these into the same denominator. Okay, but I have to do the same thing to the numerators here, up here and up here. Okay, so when I do this one here, so basically this is going to be multiplied by that and that. So I'm going to have secant of x plus the secant squared of x. Underneath, when I distribute this out, the one nice thing is because they're conjugates of each other, that is going to just end up being 1 times 1 and secant times secant, because it's going to cancel out the middle terms. Okay, so this turns into 1 minus secant squared x. Okay, over here, we're going to subtract. We'll distribute this one, so it's going to be secant of x minus secant squared of x, all over the same thing, 1 minus secant squared x. Now, before I put these together, it's going to be easier if instead of treating it as subtraction, I do plus a negative of this entire numerator, meaning I'm going to distribute a negative sign to everything. So this is going to turn to secant of x plus secant squared x minus secant x plus secant squared x. And that is all over 1 minus secant squared of x. Okay, almost there. So I can start looking at what can I simplify here. Secant of x and negative secant of x cancel out. I can put secant squareds together. So I have 2 times the secant squared of x over 1 minus secant squared of x. Okay. Now, the thing to remember about this one, to help, again, make things a little bit more simple, may not seem that way, but that's the goal. Since I am dealing with secant squared x, I'm going to recognize that I have this as our identity that we can use. Okay. So secant squared x is the same as tangent squared x plus 1. If I rearrange this, I'm going to figure out what is 1 minus secant squared of x, because I want to simplify it into just like one term versus having 1 minus like that. So if I do that, I'm going to have 1 minus. I'm basically just like swapping these two. So it's going to be a negative tangent squared x equals 1 minus secant squared of x. Okay, so this can replace this now. So I get 2 times the secant squared of x over the negative tangent squared x. So almost there. Secant squared x and tangent squared x, I'm going to remember the reciprocal as well as the tangent property for that one. So what I mean by that is these numerator is going to be 2 times 1 over the cosine squared of x. My denominator is going to be the negative of sine squared x over cosine squared x. Okay. So from there, since I'm dividing by a fraction, that's going to be the same as taking, well, I'm going to go ahead and just take 2 divided by basically a negative 1 here. It'll be a negative 2 times 1 over cosine squared x times the reciprocal of sine squared cosine squared. So it's going to be cosine squared x over sine squared x here. So we're multiplying with fractions. These cancel each other out. I end up with negative 2 over the sine squared of x. And we don't necessarily like fractions as part of our simplified versions. So that's the reciprocal of secant. So this whole thing turns into negative 2 secant squared x. This is just one strategy. It's not always going to be, I'm showing you the one and only way this can be done. Sometimes things will take different routes and you can get there different ways. Okay. But bottom line is you need to be able to get from here all the way to here. That's what happens when we completely simplify this expression. Okay. So one last one to talk about, rewrite to eliminate fractions. Again, so our goal is to kind of get rid of our fractions as best as we can. So we got 1 plus tangent squared x as an expression that does not involve a fraction. Okay, that's my goal here. So I go back, again, this is actually my Pythagorean identity that's given. 1 plus tangent squared x is the same as secant squared x. So I'm going to turn this 1 plus tangent squared into a secant squared x over cosecant squared x. Okay, well then I can use my reciprocal identities. Secant squared x is the same as 1 over cosine squared x, and that is over 1 over sine squared x. So I have a fraction divided by a fraction, meaning that's the same as 1 over cosine squared x multiplied by sine squared x over 1. I'm taking the reciprocal of 1 over, since I'm dividing by a fraction, I'm multiplying by its reciprocal. So that turns into sine squared x over cosine squared x. Since I have sine over cosine, that simplifies into tangent squared x. So sine over cosine turns into tangent. So sine squared over cosine squared turns into tangent squared. Okay. Again, all these, it's not just one strategy to do. It just depends on what you see and how you work through, but make sure you're always making steps to try to basically get rid of the fractions as best as you can. Okay. So that is it for today. All right. So we'll keep going with different identities going forward. All right. Take care, everybody.